first presenter, Dr. Jennifer Parke, is a research professor at the Department of Crop and Soil Science and the Department of Botany and Plant Pathology at Oregon State University. Her research concerns Phytophthora diseases of woody plants and development of a systems approach for managing pests and pathogens in nurseries. Today she will present a systems approach for managing nursery diseases and pests. Please welcome Dr. Jennifer Parke.
Thank you all for coming. Let's see if I can get this adjusted here. All right. Okay, today we're going to spend about an hour talking about a systems approach. And you may be asking yourself, what the heck is a systems approach? I hope to be able to answer that question for you today. My talk today is going to be arranged according to this outline. First, I'm going to describe to you the problem that we're trying to solve, and describe then what is the systems approach, and how you might implement a systems approach in your own nursery, and then for the remainder of the time, show you some pictures, some examples that illustrate how one could implement a systems approach and best practices. And I hope we'll have some time at the end to answer any questions that you may have. And then there will be a break between my presentation and Robin Rosetta's presentation. So what is the problem we're trying to solve? The problem, or at least a major contributor to the problem, is that we are being bombarded by exotic pests and pathogens every day. Every day ships come into our ports and they're unloading lots of different things, including live plants and products made from wood. And we know that these materials harbor a lot of pests and pathogens. And they're very difficult to detect. The globalization has really meant that there's been a huge increase in the imports of live plants into the United States. Since 1967, we've had a 33% increase per decade in the amount of plants, live plants, that are being imported. Let's see if I can get this laser pointer to work. Let's see. I don't know which. Oh, here we go. So here's the number of plants that are being imported. These are in number of plants in billions. And you can see there's been a huge increase since 1967. And really, our plant inspection system is not a perfect system. It's a very leaky system. You can imagine how difficult it would be to try to detect little bugs and microorganisms that are associated with plants for planting, as they're called, live plants that are being imported in these huge shipping containers. And APHIS, our federal regulatory system, does their best to try to inspect a representative sample of these shipments, but unfortunately they cannot catch everything. In fact, there's a fair amount that gets missed. For example, in the year 2009, where we have very good data, it's estimated that about 72% of all the infested plants, that is, plants that are infested with non-native insects or diseases, actually pass through the U.S. ports without being detected. And this data shows the interception on plant imports from 2006 to 2010. And this shows the number of plant diseases, 1,623, 11,426 insects, over 2,000 species, 2,000 interceptions of mites, mollusks, and a few others, also some weeds. So we know that these materials are coming into our country every day. And unfortunately, they harbor pests. Some of these pests become established in the United States and cause problems for agriculture and forestry. And nursery plants are kind of caught right in the middle because of the tremendous diversity of nursery plants, both herbaceous and woody perennials, and all the different plant families that are represented. These uninvited guests, these bugs and diseases from other places, find a good home in some of our nursery crops all too often. And some recent examples of the problems that have come in on either live plant imports or on imported wood products are some names that you'll be very familiar with. Emerald ash borer, apple moth, of course Phytophthora ramorum, the cause of sudden oak death, Ralstonia solanacearum, the red palm borer, laurel wilt, and then most recently box blight. So we are indeed being bombarded, and it's not likely that this trend is going to turn the corner. In addition to these imported plant pests, there are a number of native pests or non-actionable pests that can have a regional impact. Okay, so they may not be regulated by the federal system, and yet they cause problems in certain regions of the United States. For example, thousand canker disease of walnut or spotted winged Drosophila. And we want to keep these things from moving around across the country. Now, that aside for a moment, I just want to point out that you guys have a really tough time working on nursery crops. Compared to other agricultural operations, nurseries are very, very complicated agricultural systems. Instead of a single type of host plant species, for example, on the right, this is an aerial view of a potato field over here from eastern Oregon along the Columbia. And here's a nursery, an aerial view at the same altitude, from the same altitude, showing you the incredible heterogeneity in a nursery here in Oregon as compared to a potato field. So instead of having just one plant species, we've got how many? Hundreds, probably. We've got different kinds of environments as well. We have greenhouses, hoop houses, we've got in-field production, container yards, we've got different kinds of irrigation schemes. So we have a very heterogeneous environment. We have lots of susceptible hosts. Many families are represented. Each of these has its own range of pests and pathogens that are associated with it and can cause disease. So this really makes pest management very, very challenging for you nursery growers. Well, the importance of nursery stock, I want to remind all of you that nursery stock is incredibly important because it can serve as a vector for these pests and pathogens. And for example, Phytophthora ramorum, the sudden oak death pathogen, we know has been spread both into North America on nursery plants, or we suspect that very strongly. And we also know that it has been moved across the country several times on nursery plants. This is a slide from Nick Grunwald's research, and he has shown, using a very sophisticated population genetics approach, that Phytophthora ramorum was introduced to North America at least three separate times. We're not sure where it came from the first time, but it did come to the Bay Area. The second time, a different clone was introduced into either British Columbia or Washington. The second time it came from Europe into British Columbia or Washington. The third time it was introduced into British Columbia or Washington. And it moved up and down the coast and then was moved on nursery plants numerous times. And why is this important? Because not only are a wide variety of nursery hosts susceptible to this disease, but it's primarily important because of the damage that this pathogen does to native forests, both in California, where it's killed over 1 million oak and tan oak trees, as shown here, but we're also worried that the oak forests east of the Mississippi could become diseased, could be wiped out by this pathogen. Hasn't happened yet. We don't know if it will, but it's an awfully big chance to take. So it's really important that nursery plants that are shipped are healthy and not spreading these pests and pathogens. We don't want this kind of a situation to occur where nursery plants in Oregon are found to be contaminated with one of these quarantine pests or pathogens and need to be destroyed. It's a tremendous economic catastrophe when that happens for the nursery, and it can damage potentially our markets for states that are importing our nursery stock. What is the need that we've got? We have problems with exotic pests. We have problems with these unregulated domestic pests. The costs for controlling the pests and pathogens are high, and there is the potential for loss of markets, causing even further economic losses. Our goal is to produce healthy plants, and the traditional approach really consists of producing something, in this case plants, and then testing them at the end of that process to see if they're contaminated. So when a plant inspector comes from the Oregon Department of Agriculture to give a phytosanitary certificate, essentially he or she is inspecting that final product. So it's all based on these so-called endpoint inspections. You inspect the product at the very end of the line. It's essentially, any pest management is essentially a reactive kind of a strategy. If you've got a problem, you deal with it. You don't necessarily know where the problem originated in your nursery, and you don't necessarily know what to do about it to correct it. All you know is that the plants that are ready to be shipped are contaminated. It's all based on detection of the pest or pathogen. And we can see why that might not work. We know that endpoint inspections are not adequate because contaminated plants do get shipped around all the time. Well, what are some of the reasons for this? Well, it may be that the host plant was sprayed with a pesticide which masks the development for a while of the pest or pathogen, so you don't necessarily see it, and yet a few weeks down the line that plant shows disease symptoms. In the case of microorganisms that infect roots, it's very hard to see those, and it may be that the plant can be infected and yet not yet showing symptoms. And then the detection threshold is really pretty high. There has to be a fairly high concentration of little bugs before you notice them. So it's an imperfect system, and we know it's not working. It's also not working, we see with our most recent example, the new poster child for a systems approach would be the disease called box blight. How many of you have heard of box blight? Everybody? Just about? Okay, anyone who grows boxwood, I'm sure, knows about it. This is a problem, it's been a problem in Europe for some time, but it just showed up in North America for the first time in October in a North Carolina nursery, and now it's popping up in several different states, and it has been detected in one nursery in Oregon. It's caused by a fungus called Cladosporium buccicola. It seems to have a rather narrow host range, namely just pretty much on boxwood, but all the cultivars seem to be pretty susceptible. And so here's another occasion where it almost undoubtedly came on live plants from Europe, probably imported boxwood, and now it's another problem that our growers have to worry about. So I mentioned the traditional approach. What would a systems approach do for us? Well, in a systems approach, instead of just producing and testing, the whole basis for a systems approach is correcting unsafe practices in the nursery. So you correct the process, not just deal with the problem at the end. It's based on an auditing system to ensure compliance with certain standards, which are felt to be safe practices. It's a very proactive way of dealing with problems, and it's based entirely on prevention. You want to keep these pests and pathogens out, and you do so by correcting unsafe practices. So it's a very, very different approach. So today we have Exhibit A. Brand new, hot off the press, is this, I'll call it the Systems Approach Manual. It's the second edition of this booklet. Just came out today, I believe. And this book was, the production of this book was funded by a grant from the Oregon Department of Agriculture. They have a specialty crop block grant program, and the grant was given to the Oregon Association of Nurseries to create this book and to also have a series of workshops, and this is one of them. A number of people were involved in the production of this manual. John Griesbach, myself, Gary Chastagner from Washington State University, Nick Grinwald from USDA ARS in Corvallis, John Aguirre, Jeff Stone, Whitney Rideout, and Kurt Kipp from OAN. And it really has been a team effort. And I'm really, really pleased with the final product. I think it came out very well. And I'm so proud that the Oregon Association of Nurseries would fund something like this and produce such a fine product. It's now being used really all over the country. So I'm very excited about it. In case you want more copies of this, you can obtain these for free by downloading a PDF file from the OAN website, OAN Publications, and look for this Systems Approach Manual. So, how would you implement a systems approach in your nursery? I'm going to kind of walk you through this process. It's just kind of going to be an introduction to how to use this manual. The first thing you want to do is essentially conduct a hazard analysis. So you're going to analyze your nursery site for the risk of contamination by pathogens and pests. So let's see what page this is on now. If you look at the flow chart on page 16, here's a sample flow chart. Every nursery is going to be different, and this is kind of a simple way of drawing a flow chart. You'll recognize quickly that there are lots of loops and arrows going different directions in a real nursery situation. But it's very helpful to think about your production process, just like you'd be producing something else in a factory. I mean, what are all the different inputs that you have into your system? You've got potting media, you've got water, you've got retaining plant stock, you've got your chemicals that you might apply. All of these things are occurring in the process of producing your plants. So it's good to have something like that as you're walking around your nursery evaluating your site for the risk of contamination. And then you'll notice on the next page is a checklist, on page 17, a checklist on site selection, preparation, and maintenance. We'll go through this in just a little bit more detail, but essentially the way this book works is that in this chapter, in chapter 3, there are various checklists which help you identify your main areas of risk. And once you have done that, you can go to the subsequent chapters in the manual and get more detail about what those risks really are and what you can do about them. And there's guidance on various best practices that you use to correct the problem. So the checklists allow you to identify key areas of vulnerability in your nursery. We might think of these as the critical control points. And these critical control points will then allow you to intelligently choose best practices which will help you correct that problem. And you'll notice that no one's going to tell you exactly how to manage the problem. You have a great deal of flexibility in how you correct the problem. No one's going to mandate that. I'll give you some examples a bit later, but we think it's very important for there to be flexibility in how you address and correct the problems in your nursery. Not every nursery is going to be able to deal with the problem in the same way, and yet you might find a satisfactory solution that works in your situation. Some examples of critical control points in a nursery system. Just to help you think about this, here's kind of a generic nursery where we have propagation, liners, pots, and a can yard, maybe in a field, and then shipping. Here are some of the critical control points you might think about. The potting media, the water, the pots themselves, and the substrate underneath under the plants in the container yard, or the substrate or the soil in your field production system. The first thing that you'll do in your own nursery will complete these checklists, which are on page 17 through 27. And these are broken down by site selection, water management, plant procurement, propagation, greenhouses, etc. We're not going to be able to go through each of these today. I'm just going to kind of hit some of the high points. But I wanted to make you aware that these are many of the different considerations that you'll have when you're analyzing your site for various hazards. What you're really after then is identifying these critical control points. What are the key points of vulnerability in your nursery? What presents the greatest hazard? And what absolutely has to be changed for you to grow healthy plants? And you'll see that this is really kind of a risk management system. You're taking steps that will reduce your vulnerability to contamination. Okay, and then I've talked about the best practices, which are described in detail in chapters 5 through 9. So here's an example of the checklist on page 17 for site selection, and then on page 65 are the corresponding best practices for site selection. And you can read through these on your own later. For water management, there's a checklist and then corresponding best practices. And then on page 57. And then plant procurement, again, a checklist and best practices. So since we're not going to go through all of these in detail, I thought what I would do is show you some examples, and we'll pretend that we're kind of walking through your nursery and trying to identify some of these critical control points. Okay, here's some questions you might ask yourself. Is your site isolated from pests and pathogens, or are you surrounded by them? If there are known hosts in the landscape, do you check them regularly? Make sure they're not showing any disease or pest problems. Is your site well drained? Are your roads paved and graveled or rocked? Do you keep weeds under control? You make sure that native soil is not moved between sites. Actually, the more often you can answer yes to these questions, the better off you are. The more no's, the higher your risk. So here's a beautiful nursery in California. They specialize in growing native plants. But there's a problem. And that problem is they have a lot of native hosts for the sudden oak death pathogen right in the areas where they are growing susceptible hosts that they sell to the public. So these plants look all right. You can see in the background some of the oaks. And here's it's hard to see in this light. Here's a tan oak right back here that's showing a lot of death of the crown. And in this particular nursery, they were selling bay laurel seedlings, and unfortunately, it was right underneath a bay laurel tree that was shedding leaves that were contaminated with Phytophthora worm. So this is a big no-no. You want to avoid having any of these pests or pathogens in the area surrounding your areas. Here's a lovely example of a nursery where they've done a great job with A couple of different things. First of all, they're on a nice slope, and so they've got good drainage. They've got a nice layer of rock, so they don't have a lot of mud around that's going to be carried around on truck tires or equipment. Their blocks are nice and small, so that if they had a problem in one of these blocks, sorry, this isn't working too well, they would not have to destroy lots and lots of plants, only the ones in this general vicinity. They could limit the spread a little bit more easily than having huge continuous blocks. Nice job. Contrast that with this situation, where there's this is the road going to their loading area, and you notice that they've got a lot of mud. They've got a puddle here. Every time a truck goes through, it splashes water up onto the adjacent plants. Their cull pile is right next to the puddle. Phytophthora would be very happy here, and it could really be a big problem for all of these plants, as well as trucks entering and leaving the property. Well, let's talk a little bit more about water management. Think about the source for your water. Does it come from a well or a municipal source? If so, you probably, well, you won't have a problem with waterborne pathogens. But almost everyone uses a mixture of water sources that includes some surface water, like ponds or rivers, perhaps blended with these other sources. And you can pretty much guarantee that, I can pretty much guarantee that any open surface water is going to be contaminated by Phytophthora and also Pythium. And so if you do have water from a surface source, do you disinfest it before you use it for irrigation? And you'll find, I'm so happy with this, Kurt, on page 60 and 61 in your manual, you'll find a very detailed table that talks about all the different treatment options you could use that would be effective for disinfesting your irrigation water. You can take your pick. They'll all work, and some of them are very high-tech solutions, others low-tech. Of course, they vary a lot in price, but any one of these would be effective in disinfesting your water. Do you make sure that runoff does not run through your plant production areas? And do you recapture your runoff water and treat it to prevent the spread of pathogens? You don't let it go off-site. And do you irrigate in such a way that avoids overwatering and keeps leaf wetness to a minimum? These are things which will help you prevent disease problems, especially for the water molds. So here's the table I mentioned. Okay, this is just a figure for me to think about, recapturing that water and then making sure that you treat that water before using it for irrigation. Here is a retention pond, and in this particular case, you use chlorination for their water treatment. You want to avoid any kind of situations like this. Rhododendrons really don't like to swim around in water like this. Phytophthora zoospores do. This is a situation to be avoided. And of course, this is a bad situation too, where you get the standing water from plugged mesh, and when it rains, this splashes up onto plants and can cause a disease problem. And here are some rhododendrons where they were next to a road. The road was not gravel; it was just kind of a muddy road. And you can see that mud got splashed up onto these plants. And right here is a plant that is showing symptoms of leaf blight caused by Phytophthora. So you want to avoid splashing of water, contaminated water, up onto the plant foliage. And you also, in a field production system, you want to make sure that you have done everything you can to prevent standing water. You want good drainage, You want a level field or a gentle slope. But if you have a situation like this, in this case it's boxwood and the pathogen is Phytophthora cinnamomi, and you can see that the plants in this low-lying area are not doing too well. And it's not just from the water alone. We sampled these roots and they were completely rotten with Phytophthora cinnamomi. So, you want to pay special attention to the low spots in your fields. In contrast, here's a very nice situation where it's on a slope. The roads are rocked and graveled. There's no mud. There's no splashing. And here's another nice situation where, in this case, there's an irrigation ditch here next to the road, but pretty far away from where the plants are growing. And this mesh, oh, there's another picture in here, I think, is placed so that very nice drainage away from the plants and into the irrigation ditch. And I like this too. I mean, it's maybe not as pretty as the other, but they created a place for the water to drain where it was not going to be causing a problem for the plants in this bed. And this slide is here to remind me that it's very important not to let any infested water, any runoff, go into adjacent streams. This is actually from a nursery here in Oregon that was positive for remorum. Luckily, remorum was not found in this runoff water. But in Washington State, there are now several instances where the runoff water from a Phytophthora remorum infested nursery, where those streams have been found to be positive. It's very difficult to clean that up. And you can imagine what your neighbors downstream, how frustrated they will be if they have to use infested water, irrigation water that is infested with Phytophthora remorum. Okay, I want to spend a couple minutes talking about where you get your plants, plant procurement. And I've been thinking about this a lot, especially in terms of box blight. It's a perfect example of how being really careful about where you procure your plants is going to go a long way in ensuring the health of your plants. So if you propagate all your own plants on site where you are in control and you know those plants are healthy, that's going to go a long way. Or do you purchase from certified domestic sources? If you do import plants from foreign sources, I don't have that listed here, but there is a whole section in this book about how you can do that very, very carefully to minimize your risk of exposure to pests and pathogens. Do you inspect all deliveries and reject any symptomatic plants? Do you unload your incoming plants in an area that can be cleaned of any leafy debris that might have fallen off during transit? In the case of boxwood blight or box blight, contaminated leaves would be a source of the disease for healthy plants. You make sure that loads that arrive from several different sources are not commingled so that you can certainly track the source of those plants. And you segregate incoming plants for at least 30 days without moving them and commingling them with your existing nursery stock. That would really have helped probably with the box blight situation. Because we know that doesn't move through the air very readily, but it is moved on plant leafy material especially. Do you prevent equipment and workers from spreading the disease? If they are working in an area of plants that have arrived, make sure that they clean their equipment, their hands, their boots before going into the rest of your nursery. Do you leave a portion of your incoming plants untreated by pesticides so that you can see if any disease symptoms or pest infestations are present? So we usually recommend about 10% of that new material that you bring in would be set aside and not treated so you can see if any symptoms develop. Do you scout those buy-ins frequently? Do you send any questionable samples to a lab for diagnosis? do you destroy that any infested material? And if you treat with protectant pesticides, do you alternate or tank mix so that you minimize the likelihood that you'll develop resistance to those pathogens? So here are a couple slides of box blight that I decided I'd try to squeeze in. These are pictures from Kelly Ivers in North Carolina. She's the one who first discovered the disease in North Carolina. And it's a little bit hard to see here. It does not kill the plants, but it does cause a lot of defoliation. On young plants, there's some small circular leaf spots, so certainly scouting plants is a very important thing to do in this case. And you find these stem cankers and lesions, which become fuzzy with white sporulating structures if it's box blight. In North Carolina, it was still fairly limited, and so they tried to eradicate the disease by burying them in these deep pits and using and burning them essentially. But we have since learned that this pathogen, as I mentioned, this disease is now popping up in several different states, and I understand there are also some landscape finds. So the cow may be out of the barn at this point. Okay, back to your nursery. Let's think about greenhouses for a second here. Do you make sure that containers are only placed on clean, well-draining surfaces? You want to prevent the splash contamination from soil. You make sure that leafy debris is not allowed to build up on the greenhouse floor. You scout your greenhouses frequently. Do you remove and destroy infested or diseased plants? And do you thoroughly clean and disinfest your greenhouses between crops? Here's some very nice examples of super clean greenhouses. This one has a cement floor, which makes it easy to clean between crops. This is also a super clean greenhouse operation. And notice the absence of leafy debris anywhere, and of course there's no possibility of splashing up from contaminated soil underneath. And contrast that to this situation where these PRs are showing symptoms of Phytophthora, root rot, and leaf blight, and these trays were set right on the ground, and here the gravel has gotten mushed into the mud, and so every time these are irrigated and standing water accumulates, there's a possibility for splash dispersal. The other thing that this grower should do is that as soon as there's an area of diseased plants, they should be removed immediately so they're not continuing to be a source of inoculum for other healthy plants. There's no reason in the world these plants should be left here. This grower had a nice idea of just putting the growing trays up on some other trays that were turned upside down, just to give a little bit of a break between the ground and the plants. And then there's a good layer of rock here. So these steps also prevent that splash dispersal. Here's another situation where some benches are just raised a foot or so off the ground. And I like this system. I don't know how practical it is, but I like this system of holding plants upright so they don't tip over and become contaminated. Phytophthora, we know, it only takes about 10 seconds for Phytophthora ramorum to infect the foliage of plants if they tip over and the ground surface is wet. 10 seconds. So anything you can do to prevent your plants from tipping over will help you keep them healthy. They're cleaning the floor of this greenhouse in between crops. Great idea. Okay, let's talk about potting media and containers. You want to make sure that your growing media is free of pests and pathogens. And you want to make sure that if you reuse your containers, that they are disinfested before use. Or you could use new containers. Do you store your planting media in an area that's free of contamination? And do you make sure that any equipment that you use for mixing your potting equipment is kept clean and not used, for example, in a field operation? So here's an example of a problem where the grower they're growing piles of growing media ingredients right next to this muddy road, and every time a vehicle passes through, you guessed it, it becomes splash contaminated with pathogens. And we have tested these puddles for Phytophthora, and they're always infested with Phytophthora. Here's some used pots. I think most of you know that used pots can harbor pathogens of many different types. And there are a number of ways that you can go about disinfesting used pots. You can use steam, you can use a hot water dip. This is a hot water dip apparatus. And the details on how long you would have to dip them and at what temperature are all provided in the manual. This is a steaming operation with a Lindig type cart. So the potting media is inside here, and this is attached to a blower and a boiler. And then this is a mobile unit where essentially pallets of containers can be placed into this this truck and steamed at your nursery. And then in terms of scouting and training, are the plants at your nursery inspected? I would urge you to give that kind of direction to your field workers and to encourage them to learn as much as they can about the pests and diseases that are particularly critical to your operation. And certainly if you have any unusual pests or pathogens, I encourage you to make the investment of sending those samples into a diagnostic lab. You do not want to be applying the wrong pesticide or let a new disease go unnoticed that threatens the whole industry. We have some tools to help you and learn about pests and pathogens. There are lots of extension publications. This is the online Phytophthora course that I helped to develop. It's free for anyone to anyone can take this course, and you can actually receive a certification if you'd like to. Take a test, become certified, and then you become a very valuable member to your nursery. So back to our goal for a second. Remember, we wanted to produce healthy plants, and the old way, the traditional way, I should say the current way, is all produce and test. It's based on these endpoint inspections, whereas in this new method, it's proactive. We're trying to prevent problems before they start. We're trying to correct unsafe practices, and so far these best practices that we're mentioning are totally voluntary. You can see though that there might be some real advantage to growers utilizing a systems approach if they can prove that they are complying with these standards. They can reassure their customers that they're producing plants in such a way that they are very unlikely to have disease and pest problems. So one of the one next step that can occur is for a systems approach to become a nursery certification program. We're not actually saying that that's where we want to go, but I did want to make you aware of a few different systems approaches that are out there. There's the Pelargonium Offshore Clean Stock Program, which was put in place to make sure that Ralstonia solanacearum was not being brought into the country. And basically this assures that any geraniums that are produced offshore have to be grown in such a way, according to a systems approach, that they cannot possibly harbor Ralstonia solanacearum. It has been very, very effective. There's also the U.S. NCP, the U.S. Nursery Certification Pilot Program. Some of you in this room, I know, participate in that, and that was modeled after a system that was put in place in Canada. And one of the advantages of participating in this program is that if you comply with all of the standards in this systems approach, you actually can write your own, you can issue your own phytosanitary certificate. You're not dependent on the Oregon Department of Agriculture. So you have a lot of flexibility and convenience built in. And then there's the Oregon Grower Assisted Inspection Program, the GAPE program, which is really designed for preventing foliar Phytophthora diseases. That program seems to be going very well. And then I mentioned that Australia has a system called the Biosecure HACCP program, and they have done an excellent job of making sure they are not shipping plants with pests and pathogens. So the advantages to growers, what are they? Number one is economic. You're reducing your risk of catastrophic contamination by a quarantine pest and pathogen. You're assuring your customers that you're producing plants in such a way that you're not going to send them your disease and pest problems. You can market that, and the system also offers greater flexibility to you, particularly if it's coupled with a certification step, so that you might be able to issue your own phytosanitary certificates. Now, sometimes these steps are expensive. It's expensive to put in a water treatment facility. But think about how you reduce your vulnerability, not just to a single pathogen or pest, but the whole array of things that are going to be bombarding you for the next many years.